Hi, my name is David Buckley. I'm a researcher at the South African Astronomical Observatory, where I run the transient follow-up program on SALT, the Southern African Large Telescope. I'm also involved through BRICS Astronomy programs, and in particular, I'm the lead investigator for the BRICS Intelligent Telescope and Data Network. So the BRICS Intelligent Telescope and Data Network was selected as a flagship astronomy project within BRICS, and it encompasses a couple of different themes, namely the follow-up and detection of transient and variable events in the universe, and following up on big survey data or big survey observations from the likes of both the SKA when it's completed and also the Vera Rubin Legacy Survey for Space and Time. So these are two large projects that are coming online. One of them this year, the Rubin Observatory, the other SKA in several years' time. And they're basically surveying the whole of the southern skies. And one of the big challenges is to follow up the discoveries made in those surveys. And so the Intelligent Telescope and Data Network is a program which aims to coordinate those follow-up activities utilizing existing facilities within the BRICS astronomy community. So these are like observatories and telescopes in BRICS countries, or even in other countries where BRICS partners have access. And the other aspect of it is developing the infrastructure for the big data and big compute, which will need to be developed in this era of large surveys. And in particular, the use of machine learning and artificial intelligence to sift through the enormous amounts of data that are going to be generated by those respective surveys. So the program was adopted in 2019 as the flagship project in astronomy, and it involves co-principal investigators in all of the 5 BRICS countries, the 5 original BRICS countries, as well as many other investigators. So there are literally over 100 astronomers within the BRICS countries that are interested in being involved in this program. In addition, of course, with the admission of other countries within the BRICS family, then the opportunity to expand that to involve those countries also exists. So just in terms of what we're planning to do, initially we're starting fairly modestly to just utilize the facilities that we already have. And in that regard, at the South African Astronomical Observatory, there's been a program going for a few years now called the Intelligent Telescope or Intelligent Observatory. And this is harnessing several of the telescopes at Sutherland to do automated follow-up of transient discoveries. And this is being led by my colleague, Steve Potter here at the SAO. So the idea is that we're taking the human out of the loop so that instead a more efficient computerized follow-up system is developed. So this is already happening in South Africa, and the BRICS Intelligent Telescope and Data Network plans to use the same architecture, the same software systems to expand this to all of the observatories that will participate in the BRICS program, so that we have a cohesive network of telescopes globally distributed that will be ready to follow up the discoveries that will be made by, in particular, coming up this year, the Rubin Observatory's LSST survey. In addition, we have a more ambitious idea to develop new optical facilities, namely wide field 1 meter aperture telescopes, and locate them again amongst the BRICS countries and further afield, to be able to essentially monitor the entire night sky, both northern and southern hemisphere, with multiple telescopes in multiple filters, to allow the detection of much faster events than, say, would be possible with the LSST. So LSST is an 8 meter class telescope. It will work to incredible depths. It'll go down to more than 25th magnitude from co-added data. But its cadence, that is its sort of time resolution, will only be several days, because that's the time scale on which a particular field on the sky will be revisited. So the idea of the expansion of the BRICS Intelligent Telescope and Data Network is to provide new facilities, not as large aperture as LSST, but able to have a much higher cadence. In other words, to have a time sensitivity of the order of better than an hour or even half an hour. So within that period, it will be possible to see, for example, fast transient events, to be able to follow up these, because the instrumentation on these telescopes would be sufficient to do high time resolution observations, which is often quite crucial to understand the physics of what's going on in some of these types of objects. So the BRICS Intelligent Telescope and Data Network flagship project came about after a proposal process. Back in 2017, at the annual meeting of BRICS Astronomy Group in India, one of the outcomes of that meeting was that we should support the flagship program. And so there was a call for conceptual design or conceptual proposals for different flagship projects that would involve all of the BRICS countries. And these were developed over the next year or so and presented in the 2018 meeting of the BRICS Astronomy Working Group in Durban in South Africa. And the brief for this was that these programs were meant to be larger scale and with bigger impact than the traditional 2 or 3 year BRICS STI programs that have been funded to date. And in particular, the scientific goals were to be internationally competitive, compelling, making full use of the resources that we have within the BRICS astronomy community, but moreover, to have a program that again would have a big impact on human capacity development, and would be something that would involve ideally all of the BRICS countries. So when the proposals were presented at the 2018 meeting, there was I think about 18 different proposals presented, and a task team was set up to basically review all of these proposals. And the outcome of that review process was the realization that many of the separately proposed programs had some commonalities in themes. And so what happened in the end was a recommendation that the most compelling of those programs that fell within certain themes be combined into a proper full-scale proposal, which would be presented at the 2019 BRICS Astronomy Working Group meeting. And that's exactly what happened. And what came out of that was that the two highest ranked proposals that then combined all of the separate conceptual proposals in two different thematic areas, namely time domain astronomy and transient and variable astronomy, and then big data and big compute. Because of their synergies and because the two programs rely on each other to some extent in terms of the scientific gains, this one large flagship program was developed, and that is what became the BRICS Intelligent Telescope and Data Network, for which all of the respective investigators that had been involved in the original proposals were part of. And in particular, the two PIs who were proposing for these two larger scale projects, namely Professor Russ Taylor from the aspect of big data and big compute, and transient and time domain astronomy, which was led by me. We combined this into the single proposal where the two of us were sort of the two co-PIs from South Africa on this proposal. But the overall lead of the entire program, which involves two PIs covering those two different themes from each country. So that's 10 different co-PIs in total. We needed one lead investigator, which in the end I was appointed into that role. So while these scientific aspirations are very compelling and in fact very competitive internationally, it's a unique program that is not really being duplicated anywhere else in the world. So it's quite clear that the science goals are very strong, but there are challenges. So the challenges are basically regarding how we raise the funding to support this project. So at the moment, individual countries who are wanting to participate in this have been able to leverage funding from the national governments and scientific funding bodies within their countries. But to bring it to a scale of a true international project will require much more commitment in terms of funding. And otherwise, it's not really what you could call a global flagship project. So my hope is that through BRICS, that there'll be some mechanism whereby with all the countries committing to this program, that they will see fit to contribute to this program above the level that has traditionally been for other BRICS, say, science, technology and innovation programs, which are typically short tenure, 3-year programs with a relatively modest amount of funding. This needs to step up a notch to allow us to meet the full goals of the program. And that's not just building the new infrastructure or developing the existing infrastructure so that we have this network. It's also to develop things like the human capacity development aspects. So within the original proposal, we had the notion of supporting over a dozen postgraduate students and postdoctoral fellows each year throughout the BRICS family, which would allow them to participate in this program and to also meet with each other in the various BRICS countries from time to time. And in addition, like many major science programs globally, there's a large aspect of societal benefits that such programs can generate. So within the BRICS Intelligent Telescope and Data Network, there's a lot of effort being made to develop societal benefits programs. Many of them are HCD based, right from schools level to universities and postgraduate students, but also to bring it to the public. And in this regard, South Africa has sort of been leading the way with the development of these programs. More importantly, in liaising and talking with the people involved in such programs in the other BRICS countries to see if we can develop a cohesive program which would allow participation of all the BRICS members for events like, say, annual workshops, hackathons, and, those sort of things. So another project that I've been involved in, which is sort of parallel to the BRICS program, is something which was first sort of initiated a couple of years ago, called the African Integrated Observation System. So this was a science program developed within the African Astronomical Society, and in particular supported, promoted by the Science Committee of that society. And in many respects, it shares the same goals as the wider BRICS program, but this time, of course, exploiting the existing infrastructure in other African countries, particularly for optical astronomy. And so this program is going to have a similar sort of aim in terms of coordinating follow-up of time variable objects, follow-up of survey science, with the facilities that we have in about 4 or 5 different African countries. But moreover, it again promotes the idea of collaboration rather than people working in silos. So, for example, to have a wider scientific collaborative projects within AFAS, again, where a large aspect of that will be to involve early career researchers, graduate students, and so on, so that they can work together, again, by combining all of the abilities, all of the facilities and expertise within the AFAS community. So if you've made it to the end of the video, then and you have an interest in what I've been talking about, and in particular, you might want to be part of this BRICS flagship program, then I'd encourage you to contact BRICS Astronomy on all of the social media platforms or the BRICS Astronomy website. Thank you.